All right, we can start. So, so far we have seen, how to create pods, right? We have seen multiple types: pod, replication controller, replica set, deployment, daemon set, and stateful set. Correct. So these are all we have seen to create pods. Of course, we have seen, you know, to create pods and it will try to maintain the desired state. That's what it does. I mean, whatever the number we gave to run, it will run obviously, so without any issues. Even though something is gone, it will recreate that again. So we have seen that until so far, but we have never seen how to access those pods. Of course, I mean we are deploying pods. The pods are running fine. Obviously, it means whatever the application inside we are running, it will be running fine. But we have to access that application, right? In browser, usually any web application, like in where whatever we deploy in Tomcat or let's say or Nginx or Apache or anything, we have to access that from browser. So that's what we have to do. Today we'll do that. So today we have a concept called service services. So this is the concept which we'll be using to access our application. Imagine it's like um, port mapping in container. A similar thing, but not really exact, but it's similar thing. So we use this concept called service to access our pods. I mean, from outside the cluster, within the cluster. Even let's say I deploy kubectl apply hyphen f. I'll do the deployment. Okay, kubectl get po pods are running. How to communicate this pod? I want to connect to this. I mean, of course, we can do kubectl exec to go inside a pod. That's not what I meant. How to access the application which is running inside it? One thing is from within the cluster. Within the cluster means from another pod. And another thing is outside the cluster, obviously from our browser we have to do, from our laptop, personal laptop, anyway. So how to do that? So that's what we will see today. Kubernetes service concept. So usually you may remember there's a component called kube proxy, which is a networking component, which will be running in all the nodes usually. I mean, we don't install it when we connect our node to master. Obviously, this component will be running as a pod, obviously. So this is the one behind the services concept. Queue proxy is the one which handles the traffic whatever it will receive. Got it? So queue proxy, what it will do, it will assign the IP address to pods. It will route the traffic to the correct pods. Let's say we have 10 pods. So 10 are different pods, I mean different applications, let's say. I requested one application which is running in one pod. So usually service will take up that, and internally queue proxy is the one which will route the traffic. I mean route the request whatever we requested to the pod where the application is running. So that's what usually happens. We'll see now how this request will go to the pod. That is one thing obviously. What is the process of going request? I mean where is the communication here? So I just deployed a pod. Two pods are running, and I am telling that we have to use services to access the pod. I mean, whatever the application inside it. How the communication happen between these pod and this service? That's one thing. Of course, we know that queue proxy will route the traffic, but how the communication happens between services and pods? That is one thing. And another thing is types of services. What are the types of services? So these two we'll see today. So there are multiple types of services we have available. One thing is cluster IP, sorry, cluster IP. So this one of the service type, default service type, I would say. So what happens is like it's let's say you want to access a pod within the cluster. It means from one pod to another pod, which are running different applications like this. So at the time we'll be using this cluster IP. Like to like there is a pod like test pod. Let's say test deploy pod is there, and there is another pod, some sample ABC something pod. I want to communicate these two. So with the cluster IP service type, we'll do it. We'll do it. I mean, how that we'll see now, but I'm just explaining to you. Cluster IP service enables communication within the cluster. Within the cluster means obviously between pods. That's what, right? Within the cluster means obviously whatever running in the cluster. What we are running? Pods, obviously. So let's see how to create a service. Of course, we have to write an ML file. Go to our application ML lint. So API version, obviously, this V1, the service belongs to V1 and kind service. Metadata, these are common, correct? Name maybe test SVC, service. So these are common for everything. You know this. Now there will be spec obviously. So now these whatever we write now, which will have the arguments or whatever the parameters we pass to route the traffic. How to do that? So first thing is that write selector. Selector is to identify obviously that. So selector maybe something app, sorry, test. I wrote this some random thing. But usually selector, what happens is I asked you a question like just now. How the integration, how the communication happen between the test deploy, whatever the pods we ran, and the service. How the communication will happen is with the help of selector. It means, see, whatever the selectors we have here, let's say selector app is equal to test, we should use the same selector in our deployment also. Let's see what we are using. Selectors app test. So now what happens is when a request comes, it will check these selectors only. The service will check the selectors. It means internally kubeproxy will check the selectors. Okay, I got a request to selector app is equal to test. Is there any pod running with the same, is there any pod running with the same selector? Very, and it will route the traffic to that one. So that's one thing. That's the thing. I mean, that's how usually the communication happens. Based on selectors. Got it? So now for application, I'm using same app test. Where is it? Yeah. For service also, I'm using the same app test. If I use a different one, let's say test one, what it will do the service? It will look for a pod which has this label app test one, but obviously we don't have. It won't allow the traffic. That also we'll see, no problem. But the selector should be matched. So based on the selectors only, you'll be routing the traffic. The service will be working on routing the traffic. The kubeproxy also uses this. Let's say I have 100 pods, some random different applications. And maybe out of 100, only 10 pods have this selector app test. Remaining 90 pods have different labels based on their application, their requirement. So now what happens is, same thing. It will look for the selector and it will route the traffic only to the 10 pods. Only to the 10 pods. Not to other 90. Because the selectors, they're matching. The selectors are matching. Got it? Based on the selectors only, this is very important in service domain. So based on the selectors, whatever we write, it will route the traffic. So you have to make sure your application and the service which you are creating has to be same selectors. Has to be using same selectors in order to route the traffic. Got it? So is it clear? The selector, because that's very important. So now let's okay. I told, okay, I'm creating a service. Selector, okay, good. Selector, I told app is equal to test. I mean, route the traffic to the pod, which has the selector, I mean, the label or selector app test. Obviously, I have two pods running with this one. So it will go there. Now, after going, how it will connect to the application which is running inside it? Through the port number, right? Application will be running on some port number, something, whatever it is. So how do I connect? With help of port numbers. First thing we have to define protocol. So TCP, this is common. This protocol it will be used. I mean, the service will use this protocol to connect to your pod. Next is port number. So this port number is service port number. It's like we are mapping the port numbers now. So service will use port number 80. I mean, first thing it will filter out the label. Then it will use this port number 80 to connect to the application which is running inside the pod. Now, to which port we need to connect in the service? That's what we call target port. I think I'm running Nginx. So let me see. Target port Nginx 80, let's say as an example. 80. So now this is the whole service part. Generally, this is how it looks like. So this is fine. Based on the selectors only, it will go to the send the request to the pods based on the whatever the selector we have. Next, while sending the request to the pod, it will use this protocol and it will use this port number. These two belongs to service. Service use this port number. You can use any port, 8000, any port. I mean, not 8000 is not anything. 8000, let's say 8001, anything, whichever is fine. So you can use any port. Service use this port to connect to the pod. In the pod, this is the port we are expecting the traffic, correct? Where we are using this port in the container. That's what we did, right? Container port here, correct? So the request has to come here in order to access the application, just like port mapping. This is the service. So it will use, first thing it will filter out based on selector, and next thing it will send the traffic with the protocol and the service port. We have to give a target port also, because in which port the application is running in, here if you see, there are two ports in our scenario, 8080 and 80. Sorry, these two. To which port I need to send the traffic? You have to define a target. Of course, you can send to two things. We'll see that later. But for now, this is the service. And this is called cluster AP service. If you can see, I didn't mention the cluster AP anywhere. Even though I don't mention anything. By default, Kubernetes will take the cluster AP service only. Let's create a service. Let's create a service. Meanwhile, I'll log in again. So what you do is the same thing. You save it in a file, kubectl will apply, and the service will be created. And we'll test that also. I mean, how it works. That's what we're gonna do. So what is the use of cluster IP? To access the pods. I mean, whatever the applications inside it within the cluster. It means within the cluster means from one pod to another pod, like that. So now we don't have any other pods. We just have this pod where our application is running. So what we do is we deploy the service and we'll create some other pod and we'll test it. Yeah. So vi dot yes paste. Sorry. Let's go here. Control C. Copy. Yeah. So now save it. kubectl apply -f svc dot. It's created. How to check kubectl get svc? I mean service. Where is this our text? See? This is the default on Kubernetes which created. I mean, we don't use this. See this? It has even an IP address also, which is usually our server IP. That's fine. So test SVC is our name. Service port is this one. When I told you, right? So So service will use this protocol, this port number to send the traffic. Obviously, if you want to send the traffic through port only, general, I mean general terms, not in Kubernetes, general anyway. And what is the target port? 80. So it will come there. Now how to test it? Of course, of course we cannot access this from outside. I told you right. Cluster IP only for internal communication between the pods, not for accessing outside, Kubernetes cluster. How to do that? How to test the communication? Simple. Just to write, I'm just creating a new pod. Some busy box container test pod. This is create a new pod for me. Some random sample pod. Don't worry about what is busy box now. It's just an empty container. That's it. Oh, sorry, I did wrong. Wait. Obviously, little bit kubectl get po. That's kubectl delete po slash test pod. Yeah, I'm inside a pod. How to test it? Do curl to that service. Curl service. So, curl and how to connect to this service. Now, how to test this service? I mean, whether uh, to route the traffic or not. Usually, there will be an endpoint. Let me minimize this because I know you can't see that. Usually, what happens is there will be endpoint for the service which you create whenever you create. What is the endpoint is? The first is service name. Test-svc dot. Now there will be something called namespace. We haven't gone that yet. For now, let's keep it default. It will be default, the value as of now. And svc dot cluster dot local. This is the service name usually will get. If you describe the service, you'll see the same. We will describe it, don't worry. So now colon, what is the port number you want to access? 80. That's the service port number, right? We have to use the service port number. We'll try with a different port also. That's fine. Let's try. What the hell, curl is not found. Curl. Awesome. So maybe we'll use duplicate. Instead of curl, we'll use duplicate. Duplicate F1Q O F1. Let's see. Is the command correct? What I'm using. Bad address. So something is wrong. I have to see. All right. Where we're missing. Oh, shit. I have to use HTTP if we are accessing protocol. And then service we have to use like this. Let's try. I did hit enter. Yeah. Mm-hmm. Let's see if it is working or not. Let's wait. Still bad address. Let's exit from here. kubectl get pods. Pods are running. kubectl get svc. Sorry. Describe it first. kubectl pods for svc slash test-svc. Describe test-svc. Yes. Repeat blah 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 blah. Target port also 80. We can see it running 2 by 2. Okay, I'll look same namespace default. See here, where is in the default? Where is it? Test-svc, is it correct? Yes. bfalt dot svc dot cluster dot local cp. Cool. So bad address. What bad address I'm using? Maybe. So let me just check. Okay. These are all running fine. No issues. Is it restarted? That's okay. Let me check the log also. All good. Then what the hell is this problem? Let's create one more container. Let's try that. Let's try with curl now. Come on, yeah. Mm-hmm. It's, I can't download anything here. Or unavailable. Temporary and try again later. There is some issue. Some issue. Let's try. Same thing. Okay. Curl not found. We need curl. Cannot download the packages. Then let's try one. Let's create one more pod then. Hmm. We have our own pod, right? Is it test button? Okay. Pod is created. Alright, pod is created. Let's go into the pod. We have the sort of test system. Okay. Curl is this. Yes. Curl. Let's try here. HTTP colon test svc dot default dot svc dot cluster dot local colon 80. Let's try this. If it is not working, some issue. That's some issue. We have to see that one. Could not resolve host. Okay. So let's look at it here. Okay. Okay. There is some wrong there. Connection time of no server could be reached. So if there is some wrong, let's try now. Service is created. Go to target port. Very good. Mm-hmm. We do have endpoints. Port. Okay. What's wrong here? DNS some issues there. Let's try maybe with the port number. Mm, let's try with this. Yeah, now it's coming. Okay, welcome to engineering. I believe there is some issue with DNS. I have to check that one. DNS means we can't use the domain name here. This domain name have some issue. It should be correct, but yeah, something wrong. Is my spelling correct? Test SVC. Test SVC.default. Okay, something is wrong here. That's fine. But you can see you can access when you create a service, you will get endpoints like this. See, you can just simply copy it, do curl, simply paste it, so it's working. You can do the same thing. This is the welcome to Nginx page, usually the default page. Same thing has to work. It should work with this also. Where is this domain? But some issue I need to check once. It will take time, but yeah, usually it will work. This is the domain name format. Usually it will be. So now we cannot access it from outside, obviously. So that's it won't work. So now let's try, try to update the service. Maybe with a different port number instead of 80. So anyway, our application is running on 80. So I want to change the port number of service to maybe 8000. Yeah, let's try. Kubectl apply hyphen f svc. I changed it, so obviously I have to update. Kubectl describe, sorry, svc slash test hyphen svc. It's created the 8000 port number. Target port is 80, obviously. Correct. So now you can use the port number. Let's try. Or test port curl. Let's try with this. Space 1000. Wait, that's the host port. Sorry, that's the service port. Now do, where is it? This is the IP, service IP, right? Curl service IP colon 8000. It should work. See, Nginx. This is service IP, which is what we got. Where is it? Here. Got it? So we have to access with service IP and the port number. I mean, not IP mandatorily because IP may change, once you delete and create a service. But you'll be usually accessing the DNS name. It's not working for some reason, but usually it will work. So that's how usually we can able to access the pod from within the cluster. So as of now, you did not directly, access the pod. You access the service with the service IP and the service port number, and the request is forwarded to, what is that, the pod wherever you're running. Correct. So the pod is running. I mean, the container is running in 80 port number Nginx, and we are using 8000 port from service. So the request should be forwarded, obviously. Now we can add one more also. Let's say now we have two containers, correct? So obviously, if you just simply change this port number to 8000, it will go to the Tomcat. But I want to have two. I want to have two sections like this. One is for Nginx, one is for Tomcat. Another one maybe. Correct? How to do it? You can simply just update the file. What you do is, let's sorry. This is already there. Now what we have to do? Same thing. Let's non copy paste it. Protocol TCP port. Use a different port here. Maybe 8001 and target port. What is the target port? 8080. That's Tomcat port number. That's what usually we'll see. That's it. So all you have to do is have a new section. Let's save this and apply this obviously. kubectl apply hyphen f svc dot. It's wait. Like 401 require the value. What value I already gave? Oh, we have to give a name. Wait a minute. Let's see the error. We have to give a name because we're just giving. Sorry, let me open the file. So we just gave two port numbers. It's not taking it because it's two almost similar except the port number is same, right? So that's why we have to give a name to just to differentiate. Let's go here. Of course, the name should be unique. How to define a name? Simply go here. Anyway, maybe let's see. Instance name. HTTP something. Now since we can remove this, since it's already specified in the name, so you don't need it. Instance name Tomcat. Save it. Let's try. It's created kubectl. Sorry. It has CC two ports. Usually the two service ports are there. One is for Nginx container, I mean in the pod. Another is for Tomcat. Describe it. Uh, Two are there. ET HTTP. That's what is the name we can Tomcat. Let's create a new pod. I mean, and try it. I mean, I'm just creating another pod. I mean, not in the same pod. There is some test pod. I'm just creating. Curl. What is the IP? Copy paste. Sorry, copy paste it. If you want to access Nginx 8000 service port, you have to, because that's what we have mapped. If you want to access Tomcat, this is a 404.4. That's the Tomcat default page. Usually it will come even if you access in the browser. See, Apache Tomcat. See, that's how you access the pod within the cluster. It means from one pod to another pod, obviously. Of course, we will be using service name because IPs will change. Service name will be using. Maybe I'll fix the error. Maybe next class we'll see how it works. So that's about cluster IP. Is it clear how the cluster IP works? We create a, I mean, generally we create a service and we define a selector. Based on the selector, it will route the traffic if the selector is matching to any specific pod, and we define the ports. Based on the ports, service will leave the service port number, and we have to define a target port number. Target port number is where the application is running within the container inside a pod. So the traffic will be routed. Still, we cannot able to access the application outside the cluster. As of now, within the cluster only. I mean, within the cluster means obviously within the cluster pods will be running. So one pod to another pod communication usually we just did. Correct. Now, how to access the application from outside? Got it? What I'm saying? It's outside of the cluster. As of now, we're still seen only inside. Whatever I've seen now, I want to see in my browser. Correct? So how to do that? So there is one more type of service called node port. So based on the port number, we'll be accessing the service from outside the cluster. So this node port service exposes the service actually, not the it won't expose the pod. It will expose the service with a static port number. Usually we give the port number, right? So with the port number, we can able to access exposes the service with a static port. By default, the range is like 30,000 to 32,767 range. Within this range, it will give you a port for you. I mean, we have to define it. We can use it. So this is the default range. We can change it. I mean, usually the port range will be like 0 to 65535, I believe. From any of these ports we can able to use. But Kubernetes by default using 30,000 range. This range it is using. So we have to use any of these port numbers and we can able to access from outside the cluster. Let's see how to do that. Same thing, obviously. Oh, I have to change. Let me delete it first, maybe. So deleted. Let's keep the same name. Spec. Okay, spec won't change. This is fine. Port number also okay. Protocol service port number. Target also 80. Now extra things will be added for the node port. So what is that is? First thing in the selector, we have to define a type node port. The type we have to define node port. Correct? Because we are creating a node port service. And another thing is we have to define below what is the port for the node. Node port is maybe 30,001. Just like that, an example. I told you right. This range. So we have to define a type and the node port. Usually default range. So this service will expose this will be exposed by using this port. So when you access the service, obviously the request will go to the pod. Let's try this. Open the file, paste, save it, apply, created, kubectl get svc. If you see here, the port is mapped right. See? Now go to your browser, access with 30,001 port. First thing I download the firewall. This is not part of Kubernetes. I just allow the firewall. That's it. But imagine it's already allowed in the scenario. Come on. Come on. 30 I'm allowing all the ports. Okay, and now what you do? Go to instance. Sorry, details. My master IP. You see, I'm just going here. Paste. What is the port number? Service port number 30 blah 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 1. Let's see if this works or not. Let's try. Did we get everything correct? Yes. Target port is 80. More service port is 80. And node port 30,000. I see. Yeah. Okay. Awesome. It's not working. Hmm. This is the node IP. Okay, master IP. Let's try with this. Come on. It won't work. Yeah, it worked. Sorry, my bad. It worked. Welcome to engineering. This is the page, right? That's how usually we do it. Let's say I want to access Tomcat also. So what you do? Sorry. Name Nginx. Remove this thing. Copy the same thing. Tomcat here. I'll just use the target port is 8080, right, for Tomcat. And node port I had to change to 3000, 30002. This is 30001, 30002. Let's copy this. Go to service. Remove all these things. Apply. Mm-hmm. Right. Yeah, it's created. It's slow a little today, but yeah. What? It should come. Describe it, maybe. It's not created. Configured. Why it is not coming? Is it stuck? But yeah, let's try this. Let's try, 3002 if it works or not. Or not working. Some issue. Where we got wrong. Okay, port is allowed, but it's not creating. Let's delete it. Mm-hmm. Now open node port. Service, obviously. We gave ports, name, protocol, okay, port, target port, node port, 30001. Second one, protocol, same thing. Same thing, yes, that should be correct. Let's try the create. Why it is not created? Ah, sorry. I deleted accidentally. Sorry. My bad. I applied a wrong file. Yes, duplicate value. There is something wrong. Now it is throwing error. Earlier it didn't throw. Duplicate value code service port name. Oh, wait. I'm using the same port, service port. That shouldn't be using, right? Maybe 808, 8000. Sorry. So this is fine. Target port, we give container port. Node port, we give, which port we have to access from browser, I mean, outside of the cluster. But the port is for service port. Service usually uses this port to communicate with this thing. But we gave the same port twice. So now it should work. We have to use different ports only. kubectl get svc test svc created. See the two ports now. It is too slow today. Let's access Tomcat. Enter. See, this is a Tomcat. Of course, this is how it works usually. You have to configure Tomcat usually to to see the page. But that's fine. It's working. Is it clear? Any doubts so far? Yeah. So
Not now.
okay, I created ports with port number, blah blah. It's fine. You can access this port number. But what IP I have to use? What IP address or what the domain name or host name I have to use? You can use any, let's say I have cluster is there with a 10 nodes, maybe an example, 10 nodes are there. You can use any node IP address to access it. Any node, I'm telling you, right, to access it. So it will give you, even though the pod is not running in that node, still you can able to access with that node IP also with this port number because service is there. Service usually will be running in master and the request will go to master and from there it will route the traffic to the pods. So that's how we use the node port service to change, to access the application outside the Kubernetes cluster. So usually what we did is like we didn't like the port range. I told you right. This is the default port range. I don't want to use this port number. So what I did is I want to use 80 port number 443 to access from outside like this. Not 30,000. No one uses 30,000. So how to do it? There is usually a configuration file. I mean this not a good practice. I mean no one does this. I mean no one uses the node port service also. There is a different service which will come tomorrow. But in case if you are using node port service, in case you want to use the port number 8443, I mean below 30,000 port numbers you want to use for your application to access, you can do this. So there is a file, I forgot the file, let me change node port range. Not this. Yes, this is the file. Cube API server configuration file will be there in ATC. So we have to change it. Let's go here. Obviously, I have to use sudo. These are all the parameters for API server. And you have to add a new parameter, this one, with the service node port range. Go here, anywhere you can add maybe after this line as a argument you have to use. Same format. Just paste it. And you can change it here, maybe 0 to 30,000. Anything like this. Save it. It will usually take a minute to update. It will take a minute. I told you right because API server, if the API server is down, it means the cluster is down. We cannot access the cluster, but still we can able to access the application. Let's try this. We can able to access the application, but we cannot access the cluster. We cannot do anything. What? Why? Because we modified the API server configuration file. Because this is the main component in cluster, right? We modified the configuration. So it's restarting, it's updating the configuration. So what it will do is it will create a new pod with the configuration and the old pod will be deleted. So it will take some time. See, it's pending. See, it's trying to clean it. It will take some time. It started running. It will come on the, see, if the API server is down, we cannot access the cluster because that's the main component. If that itself is down, the cluster is down. But still, you can able to access the applications. There is no issue with that. So one by one running now. Now what you can do is first delete the service. You can change the port numbers now. So I don't want to use 30,000 now. I want to use maybe 8,000. Maybe here 8081. Let's apply. Created. See, 8,000, 8081. Now try this, it don't work because we The node port, see, gone. 8081, enter, see, it worked like that. 8000 also works. See, see how it, that's how usually we do. We access it with the node port number. So is it clear? I mean, you got it? So that's about
Yes.
node port. So we have cluster IP, node port. Still, there is one more thing. I totally read some majority of the people don't use port numbers to act in the production. They don't use port numbers. They'll be using a domain load balancers. So there is a service type called load balancer, right? So it will create a load balancer. LB means load balancer, and we can able to use that to access the service outside the cluster. Just it will work just like node port. I mean, accessing the application. I mean, the pod outside the cluster. But instead of using the port number, whatever this default range, we'll use the load balancer. So let's try creating a service type load balancer. Service type. These are all same. Let's delete the service first. Mm-hmm. Node port is type. We have to change, right? What is the type now? Load balancer. And of course, let's remove this first. One, we'll try with one. Node port, obviously, we don't need it. That's it. Name also not required because we can use the name, but it's not required. Name will be required only if you have want to route the traffic to multiple containers inside one pod. So at the time we can use name just for unique name. Otherwise we can simply skip it. That's it. Let's try creating it. It won't work, but let's see whether it will work or not. What happened? Yeah. No, why it is slow today? My network is slow. Let's try save kubectl apply -lb created kubectl get svc to be in a pending state. Obviously, it will be in a pending state. And if you see, I'll tell you why it's running. But if you see the port number here, it's automatically assigned to some random port number. We didn't mention anything, right? So what happens usually when we create load balancer services, the target port, whatever we gave here, this is the service port. This is the target port. So it will automatically assign a port number to route the traffic from load balancer to the pod, the application. And let's describe it svc slash it will be in a pending state. You know why it's pending state? It cannot create any load balancer by default. Which load balancer it will create? Let's imagine there is no load balancer in Kubernetes as of now. Which load balancer it will do usually? Nothing. There is no load balancer. Will it connect to AWS load balancer? By default, it can't. Will it connect to any other cloud load balancer or normal load balancer? It can't do that. So here directly it won't work. I mean, directly this load balancer service type won't work. Why? Because there is no load balancer to create unless if you integrate with any cloud, AWS or any other cloud, whatever you are using. So any cloud provider. So then it will create a cloud load balancer in that provider. So if not, it cannot create a load balancer anywhere. Even if you are running this cluster in on-prem, let's say normal VM virtual machine, if you use directly load balancer service, it won't work. So it will be uh, you have to integrate a third-party load balancer and outside to the service in order to work. So what I want you to do is try by yourself. You can try Metal LB. This is one of the load balancer which we can able to use for Kubernetes. I mean to configure this load balancer type. You have to configure the Metal LB. Try this or AWS load balancer. Try this. Any of this. So what's happening here is see it's running in some Linux server. Correct. This is what we are doing, right? How the hell it will know that to access outside? We can try one thing. Let's try whether it will create or not. There is something called annotations where we can able to use that. Let's try annotations. Sorry, annotations are something like an added feature where we can able to use if we want to pass any conditions kind of thing, for Kubernetes. Tomorrow we'll see more about annotations, but for now I'll try this one. Let's try this. Let's see if this works. I'm sure it won't work, but let's try. What's wrong? I mean. Come on, no, it is supposed to look like I deleted them long back. See, my network is slow. Maybe. Let's say it will work or not. It won't work, but we'll see. Created. Let's. It's still pending. It won't work. So you have to do the integration part. So I want you to do that. So what this load balancer service type will do, instead of accessing with the port number, it will create a load balancer for you. You know what does the load balancer do, right? It will share the incoming load. So I've seen somewhere. I think in Docker also we have inbuilt load balancer. So it will use that. But here in Kubernetes, it does not have inbuilt load balancer. Maybe one of the disadvantages. But that's fine. So you have to integrate AWS node if you have using AWS node, or I told you right, Metal LB. I'll share this Metal LB. So try to install the Metal LB. What is the Metal LB? How to install? Don't no no worries. Metal LB is a load balancer. That's it. How to install it is there will be manifest files for Metal LB, obviously. So there will be manifest files. Try that one. Or if it is easy for you to do with AWS load balancer, since you already might have created AWS account and practicing in there, if you're doing it, you can try that also. So this is the load balancer service type. It will create a load balancer for you, third-party load balancer, because internally it does not have anything. So that you can use the load balancer to access the service. There is one more service. I never used this, the fourth one. Let's, but I know it's like a, what is it? What is, I forgot that name. Let's see. I just remembered it. Let me just think about it. What is it? Cluster IP, obviously, it's node port, okay, load balancer, okay. There is four, yes, the thing called external name. Sorry, this I never used it, but I'll explain what is it. I mean, I haven't seen who used it, but external name is like, let's say you have a domain name, google.com, abc.com. You directly use the external name in the service. Simply go here usually. Yeah, remove all these things. It's not required. So type service, type here external name, and you have to give your external name here. Like, what is the domain name? Oh, sorry, maybe google.com like this. If you have any domain name. So now this domain will be linked to this service. And when you open this google.com and your domain name, the service will open. Obviously, the application will open. But no one uses this directly here. No one. I believe no one uses this because there will be lots of setup to use the domain name. We have to purchase it. We'll be keeping it somewhere. So we'll be usually pointing these domain names to load balancers, not directly in the service. Got it? That's why I never used it so far. I mean, just an idea I'm giving you. So these are all four services we have. Map a domain name to service. Simple. Maybe I'll keep like this. Or cloud. Got it? So these are all types of services. So services just will be used to to access your application, how you access the application. So one is like within the cluster. If you don't have a service, try running a two pods, try to communicate. How you communicate? With the pod IP, you can't. So try that one also. So service concept is there to enable the communication. One is within the cluster. I mean between the pods, obviously, cluster IP, and another is node port to access outside the cluster using a static port number. The default range is 30,000 to 32,767 port range. You can change in kubeAPI server configuration file, but not a good practice though. Keep it as it is. And just showed you and way, that's it. And of course, there is a third one load balancer. It will create a third party load balancer without the port number. It will create a load balancer. With the load balancer, we can able to access the application in the pod. Fourth one, we have external name where it will use, we can point to a domain name to the service directly, which no one does. So is it clear? These are all the service types. Any doubts so far? So of course, I try to create this load balancer service. It won't take much time since already I couldn't able to show here. But try by yourself, and if you have any doubts, we'll discuss. Got it? Is it clear? So try it out, practice, and
Yes.
tomorrow we'll have class at 7:30 p.m. Okay. So today we started at 7, tomorrow 7:30 p.m. So please be available. Let others know to join also. Got it? So let's practice this service. You know what is no, you got it right. I mean, what is the use of this service? So practice that, and we'll see tomorrow. All right. Bye everyone.